Homework 2.1, Basics of Functions, Video 3. Homework due Friday, May 22nd, 2020 at 11:59 p.m. In this video and the next one, we're going to talk about a concept or a notation called function notation, and this is something you may already be familiar with. In fact, if I give you this question, I'm thinking that most of you, if not all of you, could probably answer the first part without me running interference. But before we get to that, I want to talk about what function notation is and what it means. Function notation is this notation here. This is not f times x. It is not a multiplication problem. This letter f is the name of a function. In this case, it's this one. Now, how do we know this is a function? We'll talk about that in a second. The way that you read this is you say f of x. It's almost like the f is a verb, and we're going to do something to whatever number is in here, and this is what we're going to do to it. So most people know that when you do a function notation problem, whatever the input is, whatever's inside the parentheses gets substituted, and then you evaluate the resulting expression. The value that you put in is called the input, and the value that you get out is called the output. Imagine that. So let's do one of these, and we'll talk a little bit more about function notation and how it relates to x's and y's. So let's take a look at this example. If f of x equals 3x minus 8, evaluate f of 5, f of x plus 2, and f of negative x. Well, the first one's pretty straightforward. A function notation problem should give you two pieces of information: what to do and what to do it to. This function says, give me something, I will triple it and then subtract 8. So that's what I'm going to do. This is what I'm going to do it to. So all I have to do is substitute the 5 and run with it. Now that's pretty straightforward, but I want to show you a gimmick for setting up any function notation problem, regardless of whether the input is a constant like 5 or a variable expression like x plus 2 or x. The safest way to set up any function notation problems is to first copy the function but replace every x with an empty parentheses. So instead of 3x minus 8, I'll put 3 parentheses minus 8. Then fill in this parentheses with whatever's in this parentheses. And again, it may be overkill for this first example, but on the next two it will pay dividends. And then just work out what you set up. 3 times 5 is 15, but we haven't subtracted 8 yet, and 15 minus 8 is 7. So for this function, f of 5 equals 7. By the way, the letter f is generically used because function starts with f, but the truth is the name of a function is arbitrary. I could call it f of x, g of x, w of x, I don't know, theta of x if you want to use the Greek alphabet. I can even say something like Fred of x. Nobody said a function has to be a single letter. It usually is though. Now, when you do a function notation problem, when you put in an input and get out an output, it's important to know that the input is an x value. That's usually pretty transparent because there's an x here. But I'm claiming that this function notation represents a function which at its core is a relation, which is a set of ordered pairs which has x's and y's. Here's the x, but where's the y? Well, the input is the x, and the output is the y, which means every time you do a function problem, you have created an ordered pair. In this case, I put in a 5 and I got out a 7. Now, you don't have to worry about whether or not this is a function. It will only produce one value at a time, which is what makes it a function. Let's take a look at the other two function notation problems. By the way, this is modeled off of homework questions 5, 6, 7, and 8, and 9. Several of which have 3 parts like this one. So let's take a look at f of x plus 2. Now this really confuses some people because it's not just a number. When it's a number, they just put it in for the x and run with it. You do the exact same thing here. But if substituting an expression for x is throwing you off, then use the same gimmick that I recommended a second ago. Anytime you do a function notation problem, you can start by writing whatever the function equals, but replacing each x with the parentheses. So this is what my function is doing. Give me something, I'll triple it, and then I'll subtract 8. And guess what's going in these parentheses? The same thing that's in these parentheses. Now, you may have set up something that needs cleaning up a little bit. For example, this is screaming distribute. Okay, then I get 3x plus 6, but I still have the minus 8. And now this is screaming combine these like terms. So positive 6 and negative 8 is negative 2. So when the input was x plus 2, the output was 3x minus 2. So basically I created a new function. But it works just like when the input is a constant. You substitute and then push it as far as you can. You substitute for the x and then push it as far as you can. Normally I wouldn't write an ordered pair for this particular problem, but I could. What did I put into the function? X plus 2. What did I get out? 3x minus 2. That would be a legitimate ordered pair for this function problem. What about the last one? Well, what about it? It works exactly the same as the previous two. To find f of negative x, copy what your function does, but change every x to a parentheses. So instead of writing 3x minus 8, I will write 3 empty parentheses minus 8. Then, whatever's in this parentheses goes in this one. But what do we do here? Well, this doesn't say 3 minus x, it says 3 times negative x. So it's really not that hard to work out if you understand that a negative x is really just a negative 1x, and we're just multiplying. So what's 3 times negative 1? Negative 3. So 3 times negative 1x is negative 3x minus 8. And that's as far as we can push that one. So as an ordered pair, we could say negative x, comma, negative 3x minus 8. So when you do a function notation problem, you have to be told 2 pieces of information. Number 1, what you're going to do, that's what the function is. And number 2, what you're going to do it to, that's the input. Change each x to parentheses, fill those parentheses in with these parentheses, and then push it as far as you can.